video on data structures in the programming language Julia. We're going to cover a number of basic data structures and just demonstrate a few basic operations on each of these data structures, just to give you an overview how they work in Julia and what is similar, what is different from other programming languages. And if you would like to learn more of each of these data structures individually, then there will be other videos in which I'm going to go to each one of them in detail. So let's dive right in, and we're going to look at the tuple first. So a tuple is a sequence of elements. Usually the order is preserved in a tuple, and what's very distinct about tuples is that they are immutable. So you cannot change any of the elements or the size of a tuple once you have created it. And so that's a very unique, or let's say a very distinct property of a tuple. And what you can also do is you can make multidimensional tuples in Julia. So I'm going to show you that as well. So here in this first line, I'm making a tuple of just 3 numbers. And that's what it looks like. I'm putting the numbers in parentheses, and it gives me this tuple. I can also just actually take any type, right? So I can make character strings or text here, and I could even mix them, right? And if I wanted to look up a particular item here, I'll just go to that index 2 here, and it gives me the second element. And what might surprise you if you're used to other coding languages, then in Julia 2 actually really means 2. You get the second element, right? So you don't have to do some mental offsetting there. And you can also make 2-dimensional tuples. So here we have 2 tuples in one, and that gives me these 2 tuples. And I can index elements in these just like you would in, typically in something multidimensional. So you get here the second element of the first tuple, and that is 2. Or if you just want the entire second tuple, you just pass in one index. Let's move on to arrays. And arrays are also sequences of elements. They can be multidimensional. They very often are multidimensional if they represent matrices or tensors. And then everything has their order in an array, and arrays are mutable. So you can change the value of items. You can also change the size of an array. So let's go through some examples here. So an array here would make it with brackets. So this gives me a 6-element vector. Vector is here the name for one-dimensional array. And I can also pick the first element, that is 1.0, as we would expect now. First element really means first element. And I can also, what I'm doing here is I'm modifying the third element. I'm just going to enter the 500, which will really stand out in this. It will just tell me, yep, 500, and that's it. And if I now look in a range of an array, and that's how you do that, that probably looks very familiar to you, 2 to 4, I get exactly these, what I would expect. The second element, 2.1, the third element which I changed, and the fourth element, 2.2. Now, an array could, cannot only be numbers, it could also be, character strings again. It can, in fact, be a mix of a number of types. So here I also put a function in there. It's like the minimum function, right? And so if I create that, it gives me this vector of type any, meaning it's basically not locked in on one type, and it just lists them out again. I can actually define a type, right? So if I say I want to have an array only with integers, I would declare it like this. And if I actually then violate that condition, then Julia gives me an error. So here it gives me this error that it cannot convert this into an integer. Now it's also interesting to see, if you have, if you don't insert the commas here, then you're automatically creating a something two-dimensional, right? So here is a matrix, right, which is of dimension one row, 6 columns, so to speak. And if I wanted to just add more row vectors, then I separate them out with a semicolon. So here in this one, I have a 2x6 matrix, right? Be 2 rows, 6 columns. And of course, I can reshape that. So here, this is really a function that is built into Julia. I pass in the original matrix at my new size, and now I have a 6x2 matrix. And if I want to look at individual items right now, I can do that by just picking an index. And here it really means not the first row or first column. If I type in the 1, it really is the first element. So it gives me the 1. And if I say now give me the second element, what Julia does is it actually goes down the column first, right? So this will return me a 7. It basically goes down. This is element 2. Right? And if I were to give kind of like 2 indices here of that matrix, 2 and 1, this would actually mean, yeah, go down 2 and take the first one. That again would be 7. And if I take this one here, 3 and 2, that means I go 3 rows down, and then the second one on this row. So this will give me a 5. So much for arrays right now. There's so much more on arrays. There will be a separate video on that as well, and we're going to deep dive into a lot of things you can do with arrays. And here now is a set. So a set is a collection of unique items. So meaning you cannot put duplicates into a set, or if you do, you will not see a duplicate. You will always see at most one of these items. And a set is mutable, meaning you can change it in size, in value. Usually in these sets, the order is not preserved. So if you give items in any order, you cannot rely on those coming back in the same order. And yeah, like any collection, a set can be empty. And here we're going to do this example. So we're going to have a set of fruits: pear, apple, melon, banana. So here we have a set of 4 elements. And if I actually put in a duplicate into a set, then what will happen is it will take that in, but it removes the duplicate, right? So the banana appears only once. If I want to add something to this set, then Julia has the push method. It also has it for other data structures, right? And you see here there's an exclamation mark. This usually warns you that you're going to change something in the data structure you're operating this on. And that's exactly what we want to do. The set fruits will get a new member called apricot. And so here we are. Apricot is now inserted into this set. And as I mentioned before, the order is not preserved, meaning when you push it, you don't push it to the end or to the beginning necessarily. You could, but it could then get anywhere. So here it's right in the middle of that set. And one operation is also just getting the length of a set is also possible with this Julia function. And now let's go to dictionaries. Dictionaries are also very interesting. There is a lot more to discuss on dictionaries. Here are the key aspects of dictionaries. So dictionaries are just like in Python or hash maps and other languages where you have key value mappings, and usually the order is, or in Julia definitely the order is not preserved of these elements. The dictionary can be empty, and here we're going to look into how we're creating one. So here we're creating the dictionary with this with this call here, and we're mapping keys to values, right? And so we're mapping out attributes of a car. So we have our Toyota Prius Prime of year 2022. And if I wanted to just get the value of one particular key, I'll just put the key in like this, and it gives me the appropriate value back. And if I wanted to add another attribute, by a particular key, for example, the color, and I really like the supersonic red, not really for my own car, but I like seeing cars that have that color, then I put that in here. I can also just print out that dictionary. Here's what we have in here: make, model, color, year. And if I now was to call a key that actually does not exist, then I get an error, and that is what I expect. So, as one of the high-level functions we have here, has key, you can put in a collection and ask, does car have the key miles per gallon? And the answer is false. It does not have that key. So more on dictionaries in another video. If you want to dive deeper, here we're going to move on to string. So a string is, very typical. We have a sequence of characters here. To create a string, you usually just have to put double quotes up and type your string in there. Note you cannot use single strings for this. In Python you could, in Julia you cannot. The single quotes are reserved for characters, right? So here, this is how you make one string, here you make another one. And now let's assume we want to kind of combine them. Hello Julia, how are you? Then you have to do that with the operator of the multiplier here. So in Python you would use a plus, or in probably many languages you would use a plus. Here in Julia it's a multiplier, and you get exactly what you would expect, the concatenation of these two strings. Indexing also just like how you would expect it. If I go from 3 to 8, I really go from position 3 all the way to position 8 and get that substring out. And for indexing, you can also use the words beginning and end. That's very typical in Julia. You can do that with arrays too. And here we have, going from 14 to the end, just the question, how are you? And that is the same as if you looked for the length, essentially the last index here, and go in that subsequence as well, then you would get the same result. One more thing on strings here, because that is a popular operation, splitting a string into substrings and splitting it on a particular matching string. Here we're just gonna break it down by white space, and we get the individual words of this string. Okay, that concludes this overview on data structures in Julia. Hope you enjoyed it, and I hope to see you again in a future video. Thank you for watching.